During this lesson, we want to talk about gas ignition systems. First, though, we have to talk about a few safety devices. A thermocouple is used as a safety device to turn off the gas valve if the pilot flame is lost. A thermopile is a number of thermocouples connected in series to create a higher voltage. The thermopile can produce the voltage required to operate a coil. A thermocouple is constructed of two dissimilar metals. In other words, might be two different types of brass and copper, or two dissimilar metals. When heat is applied to the joint, the voltage is created. A thermocouple will produce up to 30 millivolts. Thermopiles, or sometimes known as power piles, will create either 250 millivolts or 750 millivolts. This is an example of a thermocouple. Thermocouple has hot junctions and cold junctions. The difference between the two creates the voltage, which will power a load. Thermocouples sit in the pilot flame. They heat up on the tip and they're cooled down at the bottom, providing the hot and cold junction. Some furnaces use thermocouples to sense the pilot flame. When the gas has been off for 5 minutes, you can turn these gas knobs to pilot position and push the knob down. Pushing the knob down opens the pilot gas valve. Light the pilot. You must hold the knob down until the pilot is lit and the thermocouple is hot. The tip of the thermocouple must be in the flame. After about 1 minute, release the gas knob. If the thermocouple is good, the pilot will stay lit. The voltage created by the thermocouple is enough to keep the pilot coil energized. The pilot coil is like a solenoid that will stay pulled in after being moved, and the voltage applied to the coil by the thermocouple. If the pilot flame goes out, the thermocouple will cool and the voltage drops very quickly to zero. The pilot coil cannot stay energized and the gas valve will close. If the pilot valve is closed, the main valve cannot open. Once the pilot flame stays lit, you can turn the gas valve to the on position, allowing the main burner to operate. The thermopile system is lit the same way as the thermocouple system. The thermopile just creates enough voltage and is used to operate the entire burner circuit. The gas valve on the thermostat are wired in series with the thermopile. When the room thermostat calls for heat, the voltage created by the thermopile will operate the gas valve. A thermopile is a series of thermocouples. This increases the DC voltage output and increases the available current. The voltage output from a single thermocouple is 25 to 30 millivolts. 10 thermocouples in series, 250 to 300 millivolts. 25 thermocouples in series, 625 to 750 millivolts. A pilot stat is similar to a thermopile. It generates enough DC voltage to hold the pilot safety valve open and energize the main gas valve. The holding circuit operates the same way as the thermocouple circuit. The thermostat is wired in series with the main gas valve. When the space temperature drops, the thermostat closes, energizes the main valve. The thermostat used in a millivolt system differs from that used in a 24-volt system. The heat anticipator operates at a much lower voltage. A millivolt heat anticipator is not adjustable. The 24-volt and the millivolt thermostat look similar but cannot be interchanged. First type of ignition we need to talk about is standing pilots. The standing pilot units are used to ignite the gas at the main burners on a conventional gas unit. The pilot flame burns at all times. The pilot flame impinges on the thermocouple, and if the pilot goes out or is not performing properly, the thermocouple will sense this and stop the gas flow through the valve. Again, the standing pilot uses the pilot flame out of a pilot burner on the thermocouple. On a call for heat, the main gas valve opens. Gas flows through the main valve to the burners. The gas exits at the main gas valve where the standing pilot ignites the gas. Main burners continue to burn until the call for heat has ended and then is shut down, but the pilot remains on. To light the standing pilot, as I said earlier, turn off the heating unit, turn the knob on a main gas valve to the pilot position, push down and hold the knob. Light the gas at a pilot with a match, lighter, sparker, or anything like that. Once the pilot is lit, keep holding down on the knob for at least 1 minute. Release the knob, the pilot should stay lit. If not, repeat the earlier steps. Turn the knob on a main gas valve to the on position. Turn power back on and turn the thermostat up. The main burners will ignite. Standing pilots can blow out due to drafts or windy conditions. Therefore, customers should be made aware of this. Customers should also be shown how to safely relight a standing pilot systems, and instructions for lighting are generally written on the heating equipment itself. Common problems with standing pilots: the pilot will not stay lit. If it's a problem with the thermocouple or main gas valve, pilot not lighting is a problem with the gas supply unit, or a pilot burner being clogged, or the pilot line being kinked or restricted. Standing pilot systems can be tested. Use a millivoltmeter on the end of your thermocouple lead. You should read 25 to 30 millivolts when flame is applied. You can also use an adapter on the end of the thermocouple lead. Again, this goes now you're in parallel with the main gas valve. You should still be able to read 25 to 30 millivolts. The next type of ignition is the spark-to-pilot ignition. It's more efficient than the standing pilot because the pilot is not lit during the off cycle. It works like a spark plug. It's used to ignite the pilot burner on a call for heat. When the pilot is lit, the flame is verified and the main burner is allowed to open. The spark provided is a 15,000 volt spark provided by the step-up transformer. The AC power from the step-up transformer causes current to jump from the electrode to the burner flame and causes the spark. The spark ignites the gas, causing the flame. The flame is a conductor. As the current moves through the flame to ground, it converts AC to DC and only allows one side of the AC current flow to ground. The process is called flame rectification. So what we're doing is we're providing some current, which is an alternating current or AC sine wave, to the flame sensor. The flame sensor, which is in the pilot flame, allows only half of that AC current to pass. The flow of current to ground is sensed by the ignition control. It verifies that the flame is lit. When the pilot flame is verified, the main burner is allowed to open, and if the pilot goes out, the DC current stops flowing to ground. The ignition module senses the stoppage of the flow and closes the main burner, thus preventing unburnt gas from spilling into the space. When the flame is verified in a spark-to-pilot system, the spark is normally shut down. Required parts of this system: you have to have the electrode sealed in ceramic insulator. Any cracks in this insulator will allow current to flow to ground and cause a weak spark. You have to have a high voltage lead wire connecting the ignition control and the electrode. This is the spark-to-pilot ignition sensor and how it mounts into the pilot burner. The spark goes from the top of the igniter onto the band above it. You also have to have a pilot spark ignition module. This is the Honeywell module, and all the connections are labeled on it. Very important, you must have a good ground from your burner. The electrode gap setting is 1/8 of an inch, but you want to verify all these gap settings with the manufacturer's instructions. There's two types of spark ignition systems. You have the 100% shutoff and the non-100% shutoffs. The 100% shutoffs mean that if there's a fault or if something happens during the ignition process or during the burn, the system will lock out the burner after approximately a time of 45 seconds. It's normally used for propane systems, as propane is heavier than air and will pool on the ground. The lockout can normally be reset by turning off the thermostat, which stops the power to the ignition control. The 100% systems may try to relight the pilot once. If the control does try and relight the pilot, this will be done one time only before the control locks out. Again, it's a safety to make sure unburnt gas doesn't pool around the furnace. Non-100% systems are used for natural gas only. Natural gas is lighter than air and will be vented up the stack if the pilot does go out. The non-100% systems will try and relight the pilot when it's blown out until the pilot is reestablished. The pilot can be blown out by wind, down the chimney, or sometimes even when power is lost. The next type of ignition is direct spark ignition. You don't see this much in residential, but mainly on rooftop units. The direct spark ignition provides direct ignition to the main burners. No pilot flame is needed or used. It creates a high voltage spark, opens the main gas valve, and the burners ignite. It proves that there's flame, the sparking stops, and all of this happens within 4 to 7 seconds. If no flame, the system will lock out and force a service call. The components that make up the system: again, you have to have your module, you have your igniter, you have a flame rod or sensor, and if it's part of the system, it's called a local sensing or single rod system. If it's remote or separate rod, it's called a dual rod or remote sensing. The ignition module provides a high voltage spark which is up to 30,000 volts. It opens and closes the main valve. It monitors gas burners for safe operation, and it will lock out if the main burners do not ignite or if flame is lost during operation. You can reset this lockout by turning the power off and then back on. These modules use a very low input voltage. It's usually 24 to 26 volts. I use 25 as my middle number. It has connections for gas valve, igniter, and flame sensor. The igniter arcs the spark to ground at one of the main burners. It has a very high voltage spark. The electrical grounds and the igniter gap are extremely important. The flame rod or sensor senses the flame using flame rectification. It sends the proper DC microamp signal back to the ignition module. The next type of ignition is the hot surface ignition. This system uses a silicon carbide element. The element can also work as a flame detector. The igniter is an electronically heated resistance heater which thermally ignites the gas. This is an example of the hot surface igniter. You have your silicon carbide tip, which is the black area, and then you have a porcelain base, which is how it is mounted. When the thermostat calls for heat, the igniter element is powered with 120 volts. The hot surface ignition is energized for 45 to 60 seconds. Then the main gas valve opens. When the main burner lights, a trial for ignition occurs. This trial lasts 7 to 15 seconds. During the trial for ignition, the igniter switches from a heater to a sensor. The sensor checks for the presence of a flame. If the ignition does not occur, the system will lock out. Some ignition systems must be manually reset, and some will automatically try a few more times to ignite. The silicon carbide igniter has about a resistance of 50 to 400 ohms. You want to check with the manufacturer for exact numbers. When energized, it should glow white. If it has a yellow glow, then the resistance is too low and the system should be replaced. It's extremely brittle and fragile. You do not want to touch it with your fingers. The igniter is supplied with line voltage. It reaches a temperature of 2400 to 27 degrees. Remember, the ignition point of natural gas is 1200 degrees. The igniter should be located so its tip extends 3/4 of an inch through the center of the flame. It should also be located about half an inch above the base of the flame. The igniter is made from recrystallized silicon carbide. It is held in a ceramic holder. Its leads are insulated with high temperature fiberglass for protection against the heat. Problems with the electronic ignition or flame rectification are almost always due to a poor ground. Make sure you run a ground wire from the burner to the equipment frame to the pilot burner to the control module before replacing the control. Often a poor ground is the cause of intermittent flame failures. With gas heat, we've continually talked about flame rectification. Flame rectification is the sensing of a flame. Every automatic ignition system needs to be able to sense when the flame is present or not. Flame rectification is this sensing of flame. Without flame rectification, we might be dumping unburnt gas into the furnace room furnace, and if there's any spark, this gas would ignite and cause an explosion. What happens is once the ignition process starts, the spark or hot surface igniter ignites the flame. Once the flame is ignited, the flame is a conductor. A very little AC voltage is sent through the flame sensor rod. The flame then converts this AC voltage and current to DC and sends it to ground. The control senses this flow of current and knows that there's a flame present. This is called flame rectification because rectification is the change of AC voltage to DC. This is an example of testing flame rectification. You have your flame rod that is connected to the flame sensor terminal on the ignition module. You take your meter lead and put it from the burner ground to the burner ground terminal on the ignition module. Change your meter to microamps and read what it says. You should have about a 2 microamps current flow. The flow of current is sensed by the ignition control. This verifies that the flame is lit. When the pilot flame is verified, the main burner is allowed to open and the flame goes out. The DC current stops flowing to ground. The control senses the stop of current flow and closes the main burner. When the flame is verified, the spark ignition system is shut down. When the flame is verified in the HSI, the hot surface igniter is allowed to cool. When the ignition process fails on a spark ignition system, there's two parts you really want to check: the sensor or the spark wire and the ground wire. The spark wire is just like an automotive spark wire. Make sure all that the contact points are good and make sure that there's no frayed or missing pieces in the insulation. Make sure all connections are tight. Replace the ground wire. Run a new ground wire from the control board to a burner assembly and back to a true frame ground of the equipment. Make sure everything is properly grounded, including the equipment to the building circuit. For hot surface ignition, check the control wire between the control and the flame sensor. Replace the ground wire again to the burner assembly, control, and flame ground. Try putting a meter in series with the ground wire on the control and the burner ground wire. The meter should be set to amps and will show around 2 microamps when the flame is present. If the amperage does not show, try cleaning the sensor or replacing the flame sensor. If the flame sensor is clean and replaced and the ground wire and terminals are good, then you have a bad control. Controls cannot be repaired in the field, they must be replaced.